Okay, so my little screen here is back now. So let's continue on then. We've described our first formula. And again, I don't need you to know how to get these formulas. I just need you to have seen somebody show you so that you'll have a little bit better understanding of this. And if you really want to learn and understand how to derive these formulas, that would give you great insight into how we're going to solve problems. But that's not a requirement here. I just need you to have seen it. Okay, so let's go to the next video.
Okay, now we want to see letter B. Using the acceleration formula, create a formula to determine final velocity under conditions of constant acceleration. So we're going to do the same thing that we did with the last formula. Remember, with the velocity formula, we said v equals delta x over t equals x minus x0 over t, and then we moved the t over here and we added the x0 and we got a formula, and then divided by v, and we got a formula that said t equals we got a formula that said x equals x0 plus velocity times time. Okay, so we moved the t over there and then we added this over there as well, and we were left with x equals x0 plus vt. We're going to do the same thing with the acceleration formula. We've got acceleration equals the change of velocity times or divided by time, and we know that change of velocity can be spread out to be v equals v minus v0 over time. Okay, it can be extended to that, and we're going to do the same thing. I want to isolate v. I want to know what my final velocity is if I have a certain set of circumstances. So I'm going to multiply by time, and that's going to give me a t equals v minus v0. And again, if you can do these intermediate steps in your head, that would be great. It's going to save you a lot of time and energy. But anyway, now all I need to do is add v0 to both sides of the equation, and that's going to leave me with v equals v0 plus at. Okay, and notice how similar these equations are. V equals v0 plus acceleration times time. Okay, so here I want to find my final position with constant velocity. Here I want to find my final velocity with constant acceleration. Okay, so hopefully it makes sense then that what we're going to call this is final velocity with constant acceleration. Final velocity with constant acceleration. Okay, so that's my second formula. We've got two formulas now. X equals x0 plus v times t, and v equals v0 plus acceleration times time. Okay, this is two of our big five, and again, these are the simplest ones because they come directly from the velocity and the acceleration definitions. Okay, all we did was just rearrange them to give us a final answer that makes more sense in certain circumstances. Okay, so go on to the next one. So we'll close this video and go on to the next one.
Okay, so that's our second formula. Let's take a look at our third formula. Another video for you to watch and...
Okay, so we're going to work on a third formula here, and the part above this line I don't need you to put down on your worksheet. What I need you to put down on your worksheet is going to be below this. But I just want to remind us that we have two formulas that we've created so far: a final position with constant velocity. In other words, how do I find my final position if I have a constant velocity? And then how do I find my final velocity if I have a constant acceleration? Okay, now let's start thinking about what happens if I don't have a constant velocity. What if I have a constant acceleration, but I don't know what that constant acceleration is, but I do know what my initial and final velocity are? So I want you to consider this, and you don't need to draw this part either. I just want you to consider this. What if I have a graph that graphs velocity at each time? So if I have 1, 2, 3, 4, 5 seconds, and I start at 0, okay, and after the first second, I'm now at 2 meters per second. After the second second, I'm now at 4 meters per second. After the third second, I'm now at 6 meters per second. After the fourth second, I'm now at 8 meters per second. And then finally, when I stop accelerating, I'm at 10 meters per second. I've got this graph that shows my velocities. Okay, 2 meters per second, 4, 6, 8, 10. Okay, now hopefully you can see by looking at this graph or just kind of inspecting this graph, if I go from 0 to 10 meters per second over 5 seconds, it will be just like I was traveling 5 meters per second the entire time. Okay? If I go from 0 to 10 in 5 seconds, it will be just like I was going 5 meters per second the entire time. Let's say that again. If I go from 0 to 10 meters per second, let's get rid of this. If I go from 0 to 10 meters per second over 5 seconds, and I do that at a constant rate, it will be as if I was going 5 meters per second the entire time. For half of the time, I would be going less than 5 meters per second. For the other half of the time, I would be going greater than 5 meters per second by the same amount. So just kind of by looking at this graph, I can tell that if I go from 0 to 10 meters per second, I'm going to actually be, it's going to be like I was going 5 meters per second the entire time. Okay, and that would be my average velocity for that time. And so all I have to do to figure out what that is like is add the initial and final velocity together and then divide that by 2. 0 plus 10 is 10, and if I divide that by 2, because I've got two values, I'm taking the average of 0 and 10, and that's going to be 5. Okay, it's just going to be like that. So 0 plus 10 is 10 divided by 2 equals 5 meters per second. Okay, so my average velocity over the entire time is going to be 5 meters per second. Okay, now let's go back then and start with my final position equals initial position plus velocity times time. We don't have our acceleration, and we could just put acceleration in here anyway, but we could pretend that instead of accelerating from 0 to 10 meters per second in our motion, we can pretend that we have a constant velocity of 5 meters per second for the entire time. Okay, so what we're going to do is we're going to say I can substitute 1/2 v plus v0 in for this velocity. Okay, because accelerating at a constant rate is just like going at an average velocity for the same amount of time. Okay, so this is my average velocity, and I'm going to pretend that this average velocity is a constant velocity. And so all I have to do then is substitute this in here, and I'm going to get x equals x0 plus 1/2 times v0 plus v times time. And this is going to give me my final position if I know my initial and final velocity. Okay, so once again, all I'm really doing here is saying that I can pretend that accelerating at a constant rate is just like going at a constant velocity if that constant velocity is the average velocity. Okay, and so we're going to call this the final position or displacement with constant acceleration formula. Okay, so we're going to call this the displacement with constant acceleration formula. And we're saying acceleration because the average velocity for the acceleration is just like what happens if we have the acceleration. Okay, I'm not really doing anything differently. I'm just spreading it out over the entire time, saying I'm going a constant velocity of the average velocity. Okay, so even if you're not quite clear on this, let's go ahead and use this formula and go ahead and look at the next formula.
Okay, so that was the third formula, and I'm going to go ahead and start another video here. I'm only at 12 minutes, but I'll run out of time before the next video finishes. So let's go ahead and start a third video here.